Okay, welcome to the part 107 study guide. And today we are going to talk about some aircrafts and the forces that acts on them. So first, we have this propeller, right? This is the propeller. So this is where it generates the thrust. So the main idea behind the propeller is that it should push the air backwards so that it creates a force on this whole aircraft that is able to move the aircraft forward. So we have a thrust that acts on this aircraft, and that thrust is generated by the propeller. So we have this force, and this is called the thrust. What is it called? The thrust. So we have the thrust like this. Okay, so once we have the thrust, we have another force that acts on our aircraft, which is the weight, right? So the weight acts down due to gravity. So this is the weight. So we have another force, which is the weight acting down, right? And after understanding that, we also have one of the most important forces that allows this aircraft to stay in air, that is called the lift. So lift is generated by this wing, right? So we have the lift. Okay, and also you know that when the aircraft moves forward, the wind blowing all over its surface is going to create drag. So we also have another force which acts on this aircraft, and that is called the drag. Drag is everywhere. So we have the drag force as well. So these are the main forces that are acting on the aircraft: the weight, the drag, thrust, lift. So we have to balance these forces in order for the aircraft to be stable in flight, right? So now we are going to speak a little bit more regarding the lift. So let me draw an airfoil. So our wing is going to look something like this. So this wing uh, is going to be some kind of a curve like that. Okay, once we have this wing, we know that when the aircraft is moving forward, we have air that flows over this wing on the top as well as the bottom, right? So when the air flows like this, it's going to create an effect of high pressure and low pressure. So the air particles will travel more distance over the top of the wing because of the curve that we have here, right? So there's a curve, so the air particles have to travel more distance than at the bottom. So this causes the pressure at the top of the wing to become low and compared to the pressure at the bottom. So we have a pressure difference, right? The pressure at the top of the wing is low and the pressure at the bottom of the wing is high. So due to this pressure difference, the the lift is created. Okay, did you understand that? So we have a net pressure, and the pressure is always flowing from high to low. So we have this upward force called the lift acting on the airfoil. So that is what is happening. So the main reason, so I told that the air has to travel more distance compared to the bottom. So here the air flowing over the wing has to speed up, high speed air, right? Compared to the bottom, low speed. That's what's creating the pressure difference. This effect is known by the scientist Bernoulli. So this principle is called the Bernoulli's principle. Okay, principle. So you have to understand this. This is how the wing generates that uplift. Okay, so we learned how a wing is going to create this upward force. Next, we'll draw a diagram that clearly defines this wing. So here I'm going to draw a wing like this. Okay, it's slightly at an angle. So in a wing we have some important parameters. Okay, so one parameter is called the chord. The chord is like the center line that runs across this, right? Uh, airfoil shape, or the cross section, right? This is called the chord. Okay, we have the chord. Okay, and also we know that the lift is generated. Uh, I mean, perpendicular to this airfoil shape, right? That's what we learned in the previous example. So we have the lift coming up. So this is the lift. The point at which the lift acts on this thing is called the center of pressure. What is it? Center of pressure. Okay. So this is what's going to happen, right? And the drag on the wing will be in the opposite direction, something like this. Okay, we have the drag. Okay, we have the lift, we have the drag, we have the chord, and based on these two forces, we have the lift and the drag, right? The resultant force will be acting in a direction that depends on the lift and the drag, right? Might be something like this. This is the resultant force. Okay, and also one of the most important thing regarding the wing is that the angle of attack. So as the aircraft is moving forward, the air flows backward, right? We know that the air is going to flow over the wing, right? So the relative angle formed between the wing and this airfoil is going to be the angle of attack, right? So say that the air is going to flow like this. So can you see? It's going to create an angle with the wind. Okay, this angle is called the angle of attack, right? Angle of attack. Angle of attack is very essential. When we increase the angle of attack, the lift generated by this airfoil will increase. So that means that if we have a greater angle of attack, we will have more lift. Only up to a point. After that point, called the critical angle of attack, the wing will stall, or it will stop producing lift, causing the aircraft stall, right? So we have these important points: the center of pressure, lift, drag, resultant force. Okay, so you have to learn these things and you have to understand how everything works. The generation of lift can be also analyzed in a simple manner, that is like this, right? Okay, let me draw the wing again. So say that we have a wing like this, and we have air flowing over the wing like this, and this wind is going to be directed downwards, right? So directed downwards, so it might like here and deflect down. So when the air is uh, here, the force acting on the wing can cause equal and opposite force on this wing, causing it to lift. So that is one other way to think about this in terms of the wind acting on the airfoil, right? So we can analyze it using the Newton's third law as well, right? Uh, so one important thing is these wings have a maximum limit, right? If the weight is greater than the max allowable limit of the aerofoil, then the wing will stall and it will not be able to generate enough lift, and the aircraft cannot climb, or it will simply fall down, right? So that's important, right? So we have to learn these concepts so that we understand what's going on, right? So let's now move and talk regarding stalling. Okay, stalls. So this is how an aircraft will fail to climb, right? That is we can say that we are losing. We are losing what? What do we lose? We are losing the ability to climb, or losing lift. We can say, right? Losing lift is called stalling, right? So how can this happen? This happens when airfoil uh, uh, is not able to generate lift, or the airfoil reaches the critical angle of attack. So earlier I explained that we have this angle created between the relative wind and the chord of the airfoil, and if this is exceeded, then the angle of attack, then we have this problem. Okay, so if it is exceeded, most likely the aircraft will stall. And also we have something called the what do you call, the stall speed. Yeah, stall speed. The stall speed is the minimum speed that we need to maintain before the aircraft will fall out of the sky. Stall speed. So you have to know that we have to maintain the stall speed, right? So like we have the stall speed, so always the aircraft should have a speed. Aircraft speed should be greater than the stall speed. Stall speed can vary depending on a variety of factors, but the important thing is that the aircraft should travel at a speed greater than the stall speed in order for it to remain in air, right? So you have to know that, right? Stall speed, aircraft speed should be greater. Okay, that you have to understand. So usually associated this condition like stalling is associated when we are traveling slow, right? So slowing down is a problem. So we have to make sure that we are traveling speed greater than the stall speed, right? Don't fly too slow. Don't fly too slow in order to prevent the aircraft from stalling. Oh, if we exceed the critical angle, then also we are going to stall. Next, let's talk about the load factor. What is it? Load factor. Now we are going to talk about lowering of the aircraft, right? So, how can this happen? So, let's take an example where the load is applied. So, say that we have this aircraft. This is the front, and we have the propeller, and we have the wing like this, right? I'm drawing the front view of the aircraft. So in this case, we have the weight and is balanced by the lift, right? Okay, we have this condition, and this is level flight. The next scenario is that let's say our aircraft is banked at an type this, right? So we have the wing that is like this. So in this case, we know that the lift will be perpendicular to the wing, but the weight will be acting directly downward, right? So now we are at an angle, so we can disturb the normal operation, and we are going to load the wing now, right? So due to this nature of forces acting, so if the aircraft banks more like this, then again we have more loading. So more loading means like yeah, it's extremely bank. Loading factor, you have to learn that the loading factor, right? The loading factor, yeah, increases with bank angle. So the important thing that you learn is that the loading factor increases with the bank angle, right? Okay, so you understand that, right? The loading factor increases with the bank angle. So if the aircraft is banked, that means it is going to increase the load on the wing, right? So and also like this loading can increase when we do unexpected maneuvers like climbing or suddenly deviating from the normal horizontal flight. It can increase the loading factor on the wing. Okay, so that thing we have to understand, right? How the loading happen. So there's another relationship that we need to learn, and this is called the relationship between the stall speed and what is it called, stall speed. Okay, stall speed also the stall speed is the minimum speed that we need to maintain before the aircraft stalls, right? The stall speed also uh, increases, right? Increases with the bank angle. So if we have more bank angle, that means the aircraft need travel much faster for it to stay in flight. So the load factor increase with bank angle causing the stall speed to go up, right? So you have to learn this thing. So we need to travel faster if we are banking, because the stall speed is now more than the normal limit, right? So and also we have a relationship between, there's a graph, and that graph will look like something like this. So here we have the load factor and we have the bank angle, right? Angle. So this graph will start at 1. So the loading on the aircraft is determined by this graph. So this like say we have a angle of 30 degrees and we need to find the loading factor. So let's say it's 1.1 at 30 degrees. So say that you have a load, the aircraft has some load, let's say 33 pounds lb. Then at 30 degrees you need to multiply 33 by 1.1 to get the loading, because now it's at an angle of 30 degrees. So at normal level flight we have a load factor of 1, but as we bank, the loading factor increases. So that's how we calculate. So we need to know this relationship, and if you need to multiply the whatever the given load with the loading factor to calculate the corresponding load, okay, at that angle. Okay, so when stalling, what to do when stalling? So let's discuss what we need to do if the aircraft is stalling. So the thing is if the aircraft is stalling, so we need to reduce the angle of attack, right? Reduce angle of attack. That is really important, that you reduce the angle of attack. If your aircraft starts stall, and we have to increase the speed, increase the engine speed or the RPM. Engine RPM should be increased, and we need to reduce the angle of it. So we should we should not be at an angle like this, right, for the aircraft. So we have to reduce the angle and gain some speed, right? So we should be trying to reduce that and gain more speed. So those are really important. And next, let's talk a bit more about the what do you call the performance, the factors that affects the performance, right? So there can be a lot of factors that affects the performance of an aircraft, especially these drones. So if you have ever flown a RC aircraft, you might know that the CG, or the center of gravity, plays a very important factor, right? So this is the wing, and we have the front propeller, and we have this rudder, right? And we have the stabilize. So CG is somewhere here. This is called the CG. Okay. So the CG plays an important factor, and also the height above the ground also plays an important factor. Height, CG, then the center of pressure is where the lift acts center of pressure, and also temperature, humidity, air density, weight, everything affects performance of the aircraft, right? So these factors are really important when we determine the performance of the aircraft. So now let's go one by one regarding the factors, right? So the first factor is the center of gravity that we labeled here. It's where the weight acts, right? So the center of gravity is where the weight acts. CG, we call it the CG. Is where the weight, right? The point at which the weight acts is called the CG. Then we have center of pressure, CP, the point at which the lift tax is applied like, so you have to learn this, right? Center of pressure, center of gravity, you should be able to like describe them. Okay, so we can change the center of gravity by changing components of the aircraft. So if you have the aircraft and if you like suddenly shift something, then you will like change the center of gravity, right? So let's say the CG was here, but say you moved some kind of a weight or a cargo box that you had over here to here, then what happens is that the CG will move back. So you have to make sure that the CG is at the correct place for the aircraft to climb normally and fly normally, right? So we have to like balance all these things in order for the aircraft to uh, be doing a very safe flight, right? So the next thing is like next we are going to talk about the effect of the CG, right? Let's say what happens when the CG is at the front and what happens if the CG is at the back. So now I will be like trying to describe you the things that's going to happen when the CG changes, right? So okay, now let's see what will happen. So say that we have an aircraft and we have no, usually it's normal to have the center of gravity or the weight acting. So we prefer the aircraft to become a little bit nose heavy. Okay, so we have the lift generated by the wing somewhere here, and we have this is the weight, and this is the lift. Okay, so here in this case, the CG is situated at front compared to the center of lift or center of pressure. So if it is at the front, what will happen? So the aircraft will tend to rotate in this way, right? So that means like it will have, but it will be slow, right? Will be slow. It will have a slower cruise speed, decrease range, because we are like trying to always climb by changing the angle, like trying to compensate for this because it is trying to naturally rotate this way, but we are like trying to add the elevator and trying to like climb all the time, so decrease range, but it will be more stable because it's trying to always pitch down, so it's easy to recover, easy to recover, it's more stable, and also it will have a higher stall speed. So that is one good point, higher stall speed. Okay, if the center of gravity is at the front, then the lift or the center of pressure, we have these properties. What if like let's say the center of gravity is behind? So if the center of gravity is behind the lift, so center of we have the center of pressure and we have the center of gravity, CG. Okay, so now we are going to discuss what happens if the center of pressure is in the front and center of gravity is in the back. So now the plane will be tail is going to rotate, right? What way will rotate? It will rotate this way. So it's going to be like having a pitch, or the nose will be trying to point upward, right? So it will be something like this, right? So it will try to like pitch up. So because this is going to be creating lift and the aircraft is going to rotate. So this is going to have allow us to have higher cruise speed. The cruise speed will be high, and also it will increase the range will be greater. That means shorter takeoff distance, right? Distance, and it will be like very hard to control. We have these problems, hard to control, right? This is hard to control, and it will be less stable, we can say that, stable, and also mm, so and also lower stall speed, right? Lower stall speed, we have the problems. So like usually for a RC aircraft, we like to have uh, the center of gravity at the front. I think it's true for the large aircrafts as well. So we have to make sure that we do not exceed these limits, because it might have very uh, we will have consequences if we are going to do that, right? So we have to like always stay within the limit and make sure that the CG is at the front. We have to make sure that the CG is at the front of the center of pressure in order for us to have stable flying conditions. Okay, to you have to learn these. So let's see some other factors. Let's see what happens when we have when the aircraft is at when the aircraft is having a high altitude. What happens? Higher altitude means the pressure will decrease, right? When we climb, when we are at a mountain, the pressure is reduced, right? Let's say pressure pressure will go down, and because the air is going to become thin, when the altitude increases, the performance will decrease, right? So these are the relationships that you need to know. So what are the other things that are going to happen? Let's say what happens if the temperature increases? If we have uh, a high temperature, what happens? High temp means again the performance will decrease. Performance will decrease with increase in temperature. So you have to know these things. You can logically think what happens if the temperature is high, the density will be low, right? Density will be low. Density decreases. Density decreases means less air. So we need to put in more engine force to create the thrust and all the things. So that's causing the performance to degrade, right? Okay. uh, we know that lift should be greater than the weight for it to stay at a stable uh, altitude. Okay, so and also what happens if the speed increase? Now say that the aircraft is like traveling faster. What happens if it is traveling faster? It's going to increase the drag, right? Speed high means drag is going to be high, because now more air is going to uh, collide and rub against surface, creating more drag, which means that the performance will decrease, right? So these are the things that are going to happen. So we have to think about all these things when we consider flying our aircraft, right? So what are the other things that we need to consider? The other things that are important as the remote pilot in command, uh, the things the length of the runway available, or the launch area. So we have to consider all these things. Suppose that you are going to launch your drone, then you have to consider the area available, right? So that you are operating this drone safely. If you are thinking about a toy RC aircraft or something, then again the area available is important, and also the surface, right? Whether for an aircraft, we need to consider whether it's slippery or something, right? Slippery, or is it icy, so that the tire the wheels have enough friction for it to take off or to land or to stop, right? And also the wind direction is important. So that's why we need to be familiar regarding these conditions, right? So wind direction is also important in that case. So you have to learn about all these things: wind direction, uh, the surface of the runaway, and regarding the obstacles around the area. So we need to really consider all these things for us to operate the aircraft safely. Okay, so and also regarding the center of gravity, what's around us, it's safe to take off, the CG limits described on the pilot's handbook or the UAS flight manual, or the what do you call the if we have bought a drone from the shop, we need to refer its manual for what is desired and what is not desired, right? So stall can occur even in the yeah the airflow is what do you call stable, right? So can occur at any condition. So So, so you have to learn all about these things and be really careful, right? When flying the aircraft, because we don't want to like damage the surrounding or the equipment that we have. So safely operate the drone. Operate the drone. So also consider these factors when you are flying the aircraft. So for this video, I think that's all I need to talk about. So hope to see you in the next video. Thank you very much for watching this video.